Hello students, you're welcome. Today we are looking at another interesting topic, one of the characteristics of living things, excretory system. That's what we are looking at. Excretory system is just one of the numerous systems that we have within our body, like our respiratory system, reproductive system, transport system, skeletal system. So your excretory system is one of the systems that we have in our body. At the end of today's lesson, you'll be able to define excretion. You'll be able to state the importance of excretion to living organisms. You will be able to state forms in which waste products can be excreted, and you'll be able to state the types of excretory structures or organ in various organisms. So let's move on by defining excretion. What is excretion? Excretion is simply the removal of waste products of metabolism. All right, we have different types of metabolism. We have catabolism. We have catabolism like your cellular respiration, and the end product of your cellular respiration is your water and carbon dioxide. So water and carbon dioxide must be removed from the body. They must not stay in the body. You should, however, note that excretion is different from egestion, because most times students do mix them up. Egestion is actually the removal of undigested food matter, which is never involved in metabolic activity. For example, if you eat bread, you eat rice or any other thing, that's your body will only absorb what it needs. Every other thing comes out, all right, as undigested food. All right, it comes out. So your igbe, your physics, is not excretion, it is egestion. All right, so let's see as we move on what are some of the importance of excretory system. Why do our body need to remove all these waste products of metabolism? We are still going to look at examples of waste products of metabolisms that are removed from our body. The first reason is that they are very toxic to our body. All right, carbon dioxide can actually lead to death of cells. All right, not just cell alone, it can affect lots of organ function even in our body. So they must be removed from our body. And how are they removed from our body? It is through excretory system. Number two, we must eliminate excess material like soluble vitamins and drugs from our body when we are sick, when we are down, or probably when we take in some things. The body will only extract or absorb what it needs. Every other thing must leave the body. It must not stay in the body. They are very, very toxic to the body, and they could cause a lot of imbalance to the environment of the cell. So they must be eliminated from the body. So when we take in our drugs like our paracetamol, anti-malaria drug, any drug that you take, your body will only absorb what it needs from that drug, and every other thing, they are toxic to the body and must be removed from the body. Another reason why we need excretory system is that it helps to maintain the pH of body fluids. All right, in our body, in the body of all living organisms, there must be an homeostatics. There must be a balance within our body. Your body must not be too the acid and the base must be balanced in our body. So the pH, it helps in regulating the pH. There are some organisms like some bacteria, some hormones that work under a certain condition. When the pH is either, if it's too acidic, they might not be able to work. When it is too alkaline, those hormones or bacteria might be affected and lots of things might go wrong. So the pH of the body must be maintained. So excretory system helps in maintaining the pH of all body fluids, not just in man but also in unicellular organisms. Let's move on. We are still looking at the importance. It helps to maintain water balance. Water must not be too much in our system. It could lead to what we call hemolysis, plasmolysis. Those are their topic on its own that we look into. That's when the salt or the water they are not balanced in your body. It could either lead to hemolysis or plasmolysis. That's shrinking of the cell or bursting of the cell. So the water and the salt balance must be balanced. The water and the salt must be balanced in the body so that the cells does not shrink. In case of, if the salt is too much, it can cause the cell to shrink, and once the cell shrinks, it can actually lead to death of some organisms, especially organisms that are unicellular. Even organisms like us that we are multicellular, our salt must be balanced. Salt must be balanced within us. All right. So also, if water is too much, it can lead to swelling and the cell can actually burst. All right. So there must be a balance. There must be an equilibrium between the water and the salt level within our body. So it's the excretory system that helps the body to do that, to maintain a balance, homeostatics. Salt is not too much and water is not too much. Then the last but not the least, waste products of metabolism, they are harmful to our body, so they must be removed from our body. Don't forget, they're also poisonous, they are toxic to our body, and they must be removed. Let's see some forms in which excretory waste can be removed from our body. The first one we are looking at is nitrogenous waste. All right, when we take in our protein, our body, the digestive system breaks protein finally into amino acids. Amino acids, those are the form that our body can absorb. So when those amino acids, when they are absorbed into the body for maybe growth, for bodybuilding, finally those amino acids, they are finally broken down, and the end product is nitrogenous products or compounds. These nitrogenous compounds, they are sometimes referred to as ammonia. All right, and they must leave our body. For example, when you take too much egg or beans, how do you feel? You at times you fat, abi, and people say, ta ló so, kí ló ń rùn, those are some waste products of protein that you have taken, ammonia, and an evidence of ammonia is that pungent smell that you perceive whenever you fat. All right, anyway, that is released in form of gas. But what about the liquid form? All right, how are they removed from our body? They have to be removed via the urine. Your urea, your uric acid, they are poisonous to the body. They have to be removed. So nitrogenous waste like your ammonia, your urea, your uric acid, in the case of insects, reptiles, birds, all right, they have to be removed from the body. Another form in which waste product is removed is your oxygen. In the case of plants, we do say that plants breathe in carbon dioxide, they breathe out oxygen. All right, and our oxygen, that's what we take in. All right, so in the case of plants, oxygen can actually be regarded as waste product of metabolism. In animal, carbon dioxide can be referred to as waste product of metabolism. So carbon dioxide is another form. Also in plants, you see your gum. All right, this is your gum here, your gum. All right, I remember when we were small, we would go and look for gum and we would harvest it on trees. All right, so your gums, they actually waste product of metabolism from tree. Your latex, all right, that's what is being converted to rubber in some area in Nigeria. All right, your even excess water, excess water from plants can be removed via the leaf. All right, we have resin, tannins, carbon dioxide, which we have said earlier on. Those are the forms in which excretory products can be removed from our body. All right, next we're looking at the excretory structures. What are some structures or organs that can help us remove all these harmful waste products of metabolism from our body or body of any other organism? The first one we are looking at is contractile vacuole. I'm going to take that again. Contractile vacuole. Unicellular organism like your amoeba, your paramecium, your euglena, they make use of their contractile vacuole to remove excess water, carbon dioxide, or waste products of metabolism. Now, when you look at this structure, you can see your sorry, let me take that back. You can see that your amoeba is about to remove excess water. All right, now can you see this first structure here? Water entering into the amoeba due to osmosis. All right, movement of water molecule, all right, via a semi-permeable membrane. Now, when excess water enters into the body of the amoeba and the amoeba needs to get rid of it, it uses its contractile vacuole. You can see the second point here. Excess water enters into the contractile vacuole. Thereafter, this contractile vacuole will move to the side very close to the membrane, to its cell membrane. You can see it. You can see that the vacuole has swelled here. That means water has moved into the contractile vacuole. Thereafter, it moves to the edge. All right, to the edge. You can see number 4. It moves to the edge of the cell, of its cell. Then thereafter, it bursts. All right, it bursts and it expels all the excess water, because if you're not careful, it's going to affect the amoeba cell if that excess water is not removed. Just like you are blowing balloon, you are putting air in it, you're putting air. After a while, what will happen to the balloon? It will burst, and that's what happens to your cell too. When water keeps entering, after a while that cell will burst. All right, so to avoid that, the amoeba needs to keep a balance, to maintain a water balance within itself, and it does that by the use of its contractile vacuole. Let's look at the next structure. Your annelida. An example of an annelida or your annelids are your earthworm. Your earthworm, they make use of what we call nephridia. And this is the structure of your nephridia. This an enlarged structure of your nephridia in green. All right, so the fluid of the earthworm, it enters through the nephrostome, then it goes through the nephridia. All the things that are essential, they are reabsorbed into the body of they are reabsorbed into the body of the earthworm. Thereafter, it comes out in form of urine. It comes out via, can we see where the red arrow is? The nephridiospore. Okay, I'm coming. Let me try and take it up. Okay, sorry, it's just somewhere here. Sorry, the brush is blocking it, but I'm just going to close it. It's just somewhere where I've marked here, down there. So it comes out there. The waste product, which is like in form of urine, the nitrogenous waste product, leaves the body of the annelid, your earthworm for example, through the nephridiospore. Then in insects, they make use of Malpighian tubules. Your Malpighian tubules, they are just like, they are these structures. Let me use my marker to highlight them. Yeah, this funny structure here. All right, that's your Malpighian tubule, and they're the one that helps your insects like your cockroach, your grasshopper, all the insects that you could ever think of. They make use of Malpighian tubule, and that's what removes excess water, excess salt, excess uric acid. In fact, in their own case, most of the time their body keeps reabsorbing water, and by the time they are passing out their waste product of metabolism, it comes out in a semi-solid form, like our cockroaches. Some of us, we see the physics around. All right, insects around us, we see their waste product of metabolism around us. All right, they comes out in form of uric acid and is usually in semi-solid form. All right, so the uric acid comes out with the physics. We can see it in we can see the red arrow. Let me just highlight it. You can see the red arrow here. All right, uric acid and physics comes out through that immediately after the hind guts. That's where it comes out from. All right, let's look at the next one. Excretory structure of flatworms. Example of your flatworms, we have your tapeworm, you have your planaria, their phylum is Platyhelminthes. All right, I think you should have done that in your classification of living things. They make use of their flame cell. All right, this is the structure of the flame cell. It helps secrete, it helps to absorb all the necessary nutrients and vitamin water back into the body of the flatworm. Then every other excess salt, excess water leaves the body via the flame cell. The flame cell acts as an excretory organ of your flatworms. In crustaceans like your crab, your crayfish, your prawn, your shrimps, they make use of what we call green gland. This is your green gland here. That's your green gland, and this is what it looks like. All right, when you expand it or when you view it under the microscope, this is what they look like, and they help in removing every excretory. They could ask you that excretory structure, excretory organ of crustacean or crab, or your your crayfish, your prawn, your shrimps. They make use of the green gland. Then arachids, your spider, all right, they make use of their book lungs, and that's the structure of your book lung. That's how it looks like. Then excretory organs or structure in your fish makes use of its gills. In some cases they make use of their kidney. Most cases anyway, they make use of kidney. All right, so we can see this, the gills here. That's the gills. Then this is the kidney, that yellow structure here. That's the kidney. We're still going to see the mechanism of how the kidney helps to remove excretory products from the body. Then in man, we make use of our kidney. We make use of, this is the kidney here. This is the liver. Oh, sorry. Let me take that back. This is the liver. This is the lungs. This is the kidney. And we also make use of our skin. Let's move on and see. This is our liver. Our liver helps to remove urea from our body. Even it helps to filter out drugs. It helps to filter out drugs too from our body. Remove toxins, like even those people that drink alcohol. Is the liver that helps to remove all the waste products that can come out from that alcohol. All right, it's actually the liver that does that, and that's why when you see people that drinks a lot, most of the time they have what we call liver cirrhosis. It can actually affect their liver. This is how unhealthy liver, this is how it looks like. All right, and this is unhealthy liver up here, and this is a liver that has cirrhosis. All right, so it's good for you not to drink, because it can go a long way to affect your liver, and I'm sure you don't want your liver to look like this. You prefer to have an healthy liver, all right, like this. All right, let's move on. Then our body also makes use of kidney. We have the right kidney, we have the left kidney. We are still going to look into kidney. We are still going to look in detail at kidney. Your kidney helps us to filter urea out of the body. It helps to regulate the amount of water in our blood. It helps to regulate even the amount of salt in our blood. All right, and excess salt is being removed via the kidney. Smaller units of our kidney our kidney, they are made up of small units called nephrons, and is actually those nephrons actually helps in filtering our blood to remove all the waste products of metabolism. So this what, when you pick, just we have billions of nephrons in our kidney. So when we pick just one unit of nephron, this is what it looks like. On that, we are still going to see the structure as we move on, how it works. We are still going to see it as we move on. And this was an healthy kidney. This is what it looks like. It helps us to kidney helps us to produce urine, and our urine contain excess water, salt, and urea. This is how the urinary system looks like. This is the kidney here. We have the aorta, the renal artery, the renal vein. We are still going to look at it into detail. We have the ureter and we have the urethra. We have the bladder. This is the bladder here, where urine is temporarily stored before it is being removed from the body. Your ureter is that tube, this long tube connecting your kidney and your bladder, while your urethra is that tube that leads from the bladder out into where your urine will pass out when you need to go to toilet. Whenever you go to toilet, that tube leading from your bladder outside, that's your urethra. All right, then we're going to be looking at lungs. Of course, in our last topic we saw respiratory system, so I'm sure we are not lungs is not kind of strange to us. So our lungs, they help to exhale carbon dioxide and inhale oxygen. All right, so water vapor, carbon dioxide, they are removed from our body via the lungs. Then our skin helps to remove excess water and excess salt, especially during perspiration. All right, that's the structure of the skin. Then don't forget that our sweat also helps us to regulate the body temperature to prevent overeating. All right, let's quickly go through the excretory structure in vascular plants. They make use of their stomata. Stomata, they are found on the leaves. All right, so your stomata can either open up or it can close. So when it opens up, carbon dioxide can go in for photosynthesis, and then it closes. Then at times it can also open up for oxygen to leave, oxygen or water to leave the plant via the leaf. So this is an opened stomata here. Then we have, if you look closely, this is a closed stomata. So you can compare a closed stomata to an opened stomata. On woody plants, they make use of their lenticel. You can see those dots. Yes, those are their lenticel. That's where exchange of gas takes place. All right, so this is what happens during excretion in plants. All right, so during the day we can see carbon dioxide entering into the leaf, all right, for photosynthesis to take place. Then in the night you can see respiration taking place, oxygen leaving the leaf. All right, because they don't make use of oxygen. They make use of carbon dioxide and they release oxygen. So we have come to the end of excretory system, or let's say the first part. We've come to the end of the first part, and in the second part we're going to be looking at mechanism of excretion in man. Thank you.